This is Greg Troutwine with Maritime Reporter TV, and we're very pleased to be joined today by Peter Fitzpatrick, Vice President, Strategic Development, the American Bureau of Shipping, to discuss evolutions in gas carrier design. Peter, to start us off, can you give us a brief on your responsibilities at ABS, as well as a short background on your experience with gas carriers?
Thanks, Greg. Really a pleasure to be here today and talk with yourselves. Currently at ABS, I have two roles, or a number of roles, but my first role is looking after what is the outlook for ABS in the next 5 to 10 years. Where do we see the markets going? How do we see the regulations changing, the technologies and the impact on the industry? And how do we then keep ABS relevant and up to date and still be able to fulfill our mission of safety, life and the property in a changing marine environment? It's changing all the time, and we want to keep embracing that change and continue to service our clients. My second role is very much, I look after ABS's Middle East operations. That's a really exciting time at the moment in the Middle East. Even with COVID, we're still seeing a number of expansion areas and projects. Qatargas is a really good example with their North Field expansion, and we're very much involved in that project as it moves forward with the new vessels, terminals and projects. But also in the region, we see ADNOC, Oman Shipping, and even Saudi Aramco embracing LNG and expanding their current business. So it's an exciting time in the LNG space in the Middle East region. I'm supporting our business, both the operations and BD in that role.
So Peter, we understand, or I understand well, that experience with gas transport ships is hardly new within the walls of ABS. Can you give us a brief overview of the ABS's history in the classification of gas carriers?
Certainly. ABS is involved in energy transportation right from the start. The first LNG carrier, Methane Princess, which was delivered in 1964, was classed by ABS. And we were heavily involved at that time in developing the rules and regulations around classification of new carriers with the Coast Guard. We've continued that relationship with both the US Coast Guard and through other organizations such as SIGTO, and we were really helpful in redeveloping and improving the International Gas Code, which was re-released and updated in 2016 as part of a rechange through the IMO, looking at how gas carriers were improving their regulations and requirements. We've also been involved in a number of other projects and keys with ABS. So ABS has been really at the forefront. So we talk about the first LNG carrier. The first LNG carrier with SPB tanks built in Japan was classed by ABS. The first LNG carrier was Saranago tanks. This is the enlarged Moss membrane tanks, Moss tanks coming out of Japan, was also classed by ABS. The first compressed natural gas carrier was classed by ABS. So we take quite pride in working with a number of companies and clients as they develop new ideas and concepts and bring them to market. Another example I can bring is the first FSRU, which has been built in Hudong shipyard. Again, will be delivered out of China. So that's a first with ABS, working with a Chinese shipyard designers and an owner looking to develop a new concept and proposal. So ABS continues to develop our rules and regulations to embrace new ideas and new challenges, because the energy industry keeps changing and adapting, which makes it quite an exciting industry to be involved in.
What do you see as the macro trends that are driving LNG carrier design today?
That's a good question. But let me take a step back. If I look at the LNG shipping industry, it's actually been under constant change for the last 15 years. LNG industry was a very traditional industry, probably from the 1980s to 2005, where you built project-specific ships. We had steam-propelled LNG ships, and the technology and the trading patterns did not change. But around 2005, 2006, a number of companies started changing. The number of importing countries for LNG increased. And so suddenly we see their different market dynamics. And the first change we're talking about is very much a market trade change. Traders began to understand they could sell cargoes to more clients, and we needed to embrace new technology. So over that period, for the last 15 years, we've embraced change from different propulsion systems. We've gone from steam to diesel electric to dual fuel gas engines. We've changed the cargo containment system. We've switched out mainly from a Moss type, the round spherical spheres, to a membrane containment system, so it can carry more volume for the same size of vessel. We've reduced the cargo containment boil-off system. We've reduced that from a 0.15 to a 0.1. And this has all been driven by the need to have a flexible shipping approach to meet the new trading demands coming forward. So we've been in a constant state of change for 15 years, and we've now kind of standardized on a new size of ships. As we look forward, I think we're going to see, as you said, another set of changes coming. So as change is no different, we're going to see this change, instead of being driven by market forces, perhaps, and how to trade LNG, this trade is going to come, change is going to come from how regulations change, how clients expect their cargoes to have a CO2 index. What is my CO2 footprint from a cargo? And this set of change is going to make a few other things, continue that progression we've made, but probably put it accelerated again to a second wave of changes coming in the next 5 to 6 years, and probably longer, as we see LNG ships evolve to be more efficient and more effective in delivering their cargo.
Now I'm going to move from the macro to the micro, and in that I mean looking at one specific ship. The very large ethane carrier Siri Everest, classed by ABS and the world's largest ethane carrier, was a great ship of 2020 in the pages of Maritime Reporter and Engineering News. Can you discuss some of the outstanding technical highlights of that ship and put in perspective its importance in the its importance to ABS and its gas ship class endeavors?
Thank you. I think you're right. It's a really important vessel. I think actually it's a very important sector. Ethane has become a major gas of export transportation. It's a byproduct. We're seeing it as a real growth area. I think the vessel, you kind of say, as we've seen that industry change, it's embraced really what's come from the lessons learned out of the energy industry. And kind of highlighted how do we take those lessons learned and then translate them into a ethane industry. I think some of the kind of first and things we like about this particular vessel, what makes it so significant, is available. It's like the LNG ships. It's able to use its own cargo as fuel. So again, we can translate. We use less energy. We take the boil off, and we handle that in the engines, which is a great part of it. We also see this one is now ready for future proofing. I think any ship owner today really needs to be thinking about future proofing their design. How do you now have your design available for the next 10, 20, even 30 years? How do you approach 2050? And these particular ships, they are kind of saying they're also LNG ready. And that's a real key step. So if the ethane trade changes for any particular reason, we've seen a number of things in the gas market changes, in market forces happen, these vessels will be able to change their operations and maybe switch from being an ethane carrier to an LNG carrier. I mean, a good example how markets can change is the US used to be a LNG importing country, and all these terminals are built. Now we've switched to be an LNG exporting country, and the vessel demands can change. So I think this is a really good vessel here, which is now flexible enough to deal very effectively with the vessel, the cargo today, burning its own cargo, consuming it and lowering its emissions, but have the flexibility to change if the market forces so demand to another cargo and another segment of the market.
As gas carrier designs are optimized to meet the ever-tightening emission targets, can you give our viewers some insights on the characteristics and the shape of the gas carriers to come in the coming decades?
Okay, good. We've kind of seen the standardization, as I mentioned before, driven by the market. We've kind of got ourselves to a standard 174, 180 size. That gives maximum vessel flexibility, maximum number of terminals you can arrive for trading. We've kind of concentrated today on a slow speed gas engine, which is the most efficient type, effectively halving the fuel consumption of the vessel from previous steam propelled vessels. We've optimized the hull form, so it's now available both on a laden passage and a ballast passage to be as efficient as possible and at multiple speeds. We've improved the cargo containment system from a boil-off rate, really improving the insulation from a 0.15 to a 0.1, even less, really looking how to optimize that. And we've also looked at how do we kind of look at the cargo handling system. Maybe we add a reliquefaction system. So we've seen a standard design come up today around this kind of concept. Going forward, I think we'll still see this kind of standard sizing, 174, 180, be flexible, but we may see a few other things beginning to come in. I think the adoption of shaft generators will be constant. How to use the main engine to generate the power. These auxiliary engines on an LNG ship, we have a lot of them at a high power load. Let's begin to use more of that. I think we're going to see a decoupling of the cargo containment system from the main propulsion. We already kind of start to see that with a lot of the ships adding reliquefaction systems. I think that's going to become more of the norm, and that's about future-proofing your design. So in the future, you can then have a reliquefaction system which maintains the cargo tank temperature and pressures, and you have a separate fuel system for the main engine. Now that can be today, it can be LNG, but as I look down 15 years, maybe it's bioenergy. Maybe in 20 years, I have to switch to ammonia or hydrogen. And by decoupling the cargo containment system from propulsion, it allows me to have other options around that area. Another area we're seeing is the adoption of energy saving devices in the hull form. I think we're going to see LNG ships are a very nice vessel from a naval architecture point of view. They're a constant draft, very similar constant speed. And I think like air lubrication, where we use air bubbles to reduce the skin friction. It has been fitted on a number of vessels, and I think it will become more common as we see forward. So I think those type of things we're going to see. I think we will see some more embracing of electrical and batteries. Again, LNG ships have a natural tendency to use a lot of electricity in port. So again, we might see the concept of cold ironing coming into more play, the use of batteries and a hybrid ship where we generate power from the shaft generators for use in port. So I think there's some small changes around these, which will be the main technical hardware changes we're going to see.
I know you've just discussed many of the technologies that are going to drive the gas carrier of the future, but there are any additional technology innovations that you see in the maritime space today that we can expect to see will be needed to support the gas carrier of the futures?
Great question. I've already talked about the hardware changes, the hull, the engines, containment system. I think the biggest change which has the most impact will be the software, the digital innovations we need to embrace to make efficient operations. I think we have to remember the LNG ships are quite interesting. As we have to consume energy to keep the cargo in its liquid format, every time the vessel stops, every time the vessel has a delay, every time we're consuming additional energy. If we want to optimize this, we need to embrace a digital approach. How we have a connected fleet, how do we have digital sensors which understand the performance in the vessel? How do we connect it to the terminals? So we can really embrace just-in-time shipping, efficient shipping, reliable shipping, predicting cargo routes. So the use of digital really allows us then to optimize the cargoes, the routes, which ships go on which routes to give the best emissions profile, which ships and which cargoes, which options give you sort of just-in-time arrive so the terminal doesn't have a tank top issue. And how do we really streamline that kind of logistics train to optimize the vessel? And I think digital allows us to do that. I mean, ABS is quite proud. We've developed a system called My Digital Fleet, which is a platform system. And the idea of the platform system here is you can embrace many, many different digital tools into one system and then connect them together to see what provides you the best opportunity to optimize your fleet looking forward. Traditional performance systems look retrospectively. How did my vessel perform in the last voyage? The digital solutions of the future are going to say, how will my vessel perform as I go forward? And if that's the case, that will then, I don't want to use that voyage. I want to do this voyage. I want to make this change. I want to use this weather routing service. I think digital will be a key enabler now to make the next gigantic leap in how we make improvements in vessel emissions and efficiency.
It's all coming down to digital, that's for sure. So, yeah. Peter, I truly appreciate your time. I just had one more question. Are there any particularly interesting projects ongoing or soon to be completed that you can discuss?
We have a number of interesting projects going forward. Some are more in the public domain. I think we will see a number of studies, perhaps in the fuel systems, reliquefaction systems we're working with. We see perhaps not so much in the LNG industry, but how do we work with engines and ammonia and transitional fuels? I think that's an exciting area which will lead into the LNG industry. I think we're seeing a number of about digital solutions and how digital works with a number of companies. We are working with a number of chartering organizations now, not just vessel owners, how those digital tools will come in. On the hardware side, we've seen a few, I think, more innovations coming out. We've had some, I think the LNTA containment system was a good example of a new containment system coming to market. And we're working with our partners in Qatargas and looking at a new MOU. How do we develop that in a different scale concept? I think there's some other exciting areas around FSRUs and smaller scale LNG systems, which will come out and produce a more hub and spoke market. How do we get LNG to a wider variety of audience as this market is expanding? And I think ABS is quite happy and proud to be working with these companies in these areas. So I think you're going to see a few more non-traditional areas, non-traditional solutions around how do we get gas to stranded markets, how do we get gas to a more traditional market, and how do we use new technologies to help us lower the OPEX, lower the CAPEX, and improve the efficiency of cargo delivery.
Okay, Peter, I truly appreciate your time. Gas carriers and everything gas is obviously topical, so I look forward to talking to you about it in the future as well.
Thanks very much, Greg. Really good to talk to you, and happy to catch up again.